Circuit elements. Resistor. A resistor is a passive component. It cannot produce energy, but it can dissipate it. It opposes the flow of electrical current. Resistance is represented by R. The value of resistor is called as resistance, and it is represented by capital R. The unit of resistance is ohms, which is represented by omega. 1 ohm is equal to 1 volt upon 1 ampere. This is according to Ohm's law. Now let's understand what is meant by 1 ohm. Here we can see this is a symbol for resistor. Now if we apply 1 volt to this resistor and the current through this resistor is 1 ampere, that means the value of this resistance is 1 ohm. Linear VI characteristics or linear VI relationship in both AC and DC. So here we can see it gives linear characteristic in both AC and DC. Here we can see this is a VI characteristic. On x-axis it is voltage and on y-axis it is current. So if we draw the graph between these two, we get a straight line. Then it dissipates electrical energy. This is the symbol for resistor. Here this R represents resistance. Resistance is the value of a resistor. This I is the current through this resistor. V is the voltage across this resistor. Now this I is given by I is equal to V by R. This is according to Ohm's law. Power absorbed is given by P is equal to V into I, or V square upon R, or I square into R. These are the formula for calculating power absorbed, and its unit is watts. The mathematical expression for the resistance of a conductor is R is equal to rho L by A. So resistance is equal to rho L upon A, where this rho is the resistivity of a material and it is constant. This L is the length of the conductor and this A is the cross-sectional area. Resistor lower the flow of electric current and its function is to regulate or limit flow of electrical current. These are the function of resistor. It is a device having resistance to the passage of an electric current. Here we can see this is the symbol for resistor. It is a passive component and it have two terminals. As we can see, this is one terminal and this is second terminal. Used to reduce current flow, adjust signal levels, divide voltages, bias active elements, etc. These are the application of resistor. Fixed resistor resistance changes slightly with temperature, time or operating voltage. So its value of resistance may be slightly changed with increase in temperature or decrease in temperature, or with time or with operating voltage. It may be slightly vary, but it is generally considered as fixed. Value of resistor can be measured with an ohm meter. We can measure its value by using ohm meter or multimeter. High power resistors dissipate many watts of electrical power. That means the more the high power of resistor dissipate many watts of electrical power. Now according to Ohm's law, V is equal to I into R, where V is the voltage in volt, I is the current in ampere, and R is the resistance in ohm. Then power is equal to I square R. This I square R is the heat. Power is represented by P and the unit of power is watt. Here this R is the resistance and its unit is omega. This is called as uppercase omega. Now what is resistance? It is a property of an electrical component to resist the flow of electric current. It is called as resistance. Again, also remember that power is equal to voltage into current or V square upon R. So these are the formula for power. Now let's see the symbols for resistor. So this is the symbol for resistor. This is the symbol for variable resistor. It is called as rheostat. And this is the symbol for potentiometer. Resistors in series. So when we connect resistors in series, that time we have to add them. Like resistance of resistor 1 is R1. Resistance of resistor 2, that is R2, up to so on. So we have to add them likewise. So we get the equivalent resistance. In series, the resistance increases. When we connect resistors in series, its equivalent resistance is increases. And when we connect resistors in parallel, that time its equivalent resistance get reduced. So here we can see 1 upon Req. 1 upon Req is equal to 1 upon R1 plus 1 upon R2 up to so on. This is how a resistor look like. Here we can see in this circuit board, this is the resistor, this is capacitor and all the other electronics component. But here we can see this is the resistor. Then again, these two are the resistors. Here we can see this is a resistor network. There are many resistors connected in this circuit or in this network. Example application number 1, LED current limiting. Now these are the application of resistor. Let's see LED current limiting. So to operate the LED, that is light emitting diode, we have to reduce its current, otherwise it will blow. So we need proper current to operate LED. Now here the supply voltage is 9 volt and the LED, that is light emitting diode, its forward voltage is 1.8 volt. So that means we need the resistance of 720 ohm to get the current of 0.010 ampere. So by varying this resistance value, we can vary this current value. More the resistance value, less the current, and less the resistance value, more the current. Maximum forward current is around 20 milliampere. So this is the maximum forward current for this LED. We can calculate by using this formula. R is equal to Vs minus Vf upon If. So it is LED's forward voltage and this is source voltage minus LED forward voltage divided by LED's forward current. So this LED forward current is given so 9 volt minus 1.8 volt. We need this much current, 0.10. So if we calculate this, we get the resistance value of 720 ohm. Then second application of resistor is as a voltage divider. A voltage divider is a resistor circuit which turns a large voltage into a smaller one. Suppose if we want smaller voltage from a large voltage, we have a voltage source of 9 volt or we have a battery of 9 volt, but we need only 3 volt suppose. So what we will do? We will add 2 resistors in series, and one resistor value will be of 2 kilo ohm and one resistor value will be of 1 kilo ohm. Now according to voltage division rule, this is the formula for voltage division rule. This is VL, that is load voltage, is equal to VS, source voltage, into R2 divided by R1 plus R2. So if we solve this, we get VL is equal to 3 volt. So by using voltage divider, we can get the smaller voltage. So this is about resistor.